Hey guys, so I was assigned or picked correlational and experimental research. So I'm hoping with me holding my camera like this and you seeing me that you can kind of get both. I decided to do a PowerPoint because I don't really like to talk to people. So hopefully this will keep me from stuttering. So correlational and experimental research. I went ahead and divided it into two separate things. It is related. They are related to each other, but I went ahead and divided them into two separate sections. I do want to start with, I did try to look at where correlational and experimental research came from or how it started, and the best I could get was a story from the 1970s about two guys who were trying to expand some kind of land and survey for it. So I didn't actually get a definite answer about when and how correlational research or experimental research started. So I'll just go with what I have, and hopefully I answered all the questions that I was supposed to answer. And if you have any questions, you can let me know. So correlational research, it does involve the measurement of two or more relevant variables and an assessment of the relationship between or among those variables. So basically it's wanting to see if one variable can affect another variable and how it affects it, whether it's a positive correlation or whether it's a negative correlation, or if it doesn't affect it at all. Variables also can demonstrate a linear relationship, linear meaning a straight line, as you can see in the picture, when the relationship between the two variables on a scatter plot can be approximated with a straight line. If you can't draw a, quote, line of best fit, then it probably isn't related at all. A lot of investigators do measure the degree of relations between two or more variables using your correlational analysis or your correlational study, and it's generally expressed in numerical form. It's generally expressed with a set of data. It's generally expressed in numbers. It does indicate whether two variables are related or whether one variable can predict another variable's outcomes. And I'll give examples of that here shortly. It is beneficial because it's a study of a single group rather than using two or three groups at a time like you would in an experiment. So like I said, they're related, but they're different, if that makes sense. So there are different types of correlation. You have a positive correlation, which is an increase in one variable that leads to an increase in another. For example, a person's education, generally the higher the education, the better their income. Not always, but generally speaking. You can also determine height versus weight. That will also generally give you a positive correlation. Not always, but generally. You also have negative correlations, and that's when an increase in one variable leads to a decrease in another variable. For example, you have the age of a child versus the number of diapers they use. So if you have a 1-year-old child, they'll probably use 15 diapers in a day. Whereas if you have a 3-year-old child who's not potty trained yet, they might use 5. So it still has a correlation, but the correlation goes down instead of up, creating a negative correlation. And you have level of education versus crime rate. So generally, the more education you have, the less crime you are to commit. And then you have things that have zero or no correlation. It's basically when the relationship between two or more variables cannot be described by a straight line like we talked about earlier. It's also known as nonlinear in a mathematic term. So education versus height. No matter how much education I have, it doesn't matter if I'm tall or short, or if I'm tall or short, it's not going to matter because that doesn't determine what level of education that I have. And being rich versus happiness. You always hear money doesn't buy happiness, so you can be rich and you can be the most miserable person. So those kinds of things have no correlation. This is just an example of the different types of correlation. You do have your positive correlation on a scatter plot. If you plot your data, you can see that your positive correlation goes up. You can see your negative correlation goes down. And you can see no linear relationship. Either you're going to be able to draw a curve or you're not going to be able to draw anything at all. It's just going to be a lot of dots and you can't do anything with that. One important part of correlational research is multiple regression. It is a technique that's based on correlational coefficients that allows predicting a single outcome variable from more than one predictor. So generally they're looking at one variable affecting another variable, but in multiple regression you can test one variable from more than one predictor variable. So for example, you can use a test to predict job performance based on more than one predictor. What a person is likely to score on an outcome variable, which is their job performance, based on knowledge of other variables. As far as correlational research strengths, it can be used when experimental research cannot be used due to certain predictor variables that cannot be manipulated. We'll talk about manipulated variables when we get into experimental research. It does allow the researchers to study behavior as it may occur in everyday life. It is generally done in a natural environment, so you're able to more see what variable can affect another variable based on the environment that they're in. And I'm particularly thinking about students' behavior just because that's what I do for a living. So what can trigger a student's behavior and how can we change that in order to get more positive behavior? And it can be used to make predictions about two or more variables. So if I eliminate one variable, maybe this other variable will increase or decrease or etc. There are some limitations, as there are with every types of research studies. Your correlational research limitations are that they cannot prove that one variable causes change in another variable. You can make a prediction and you can make a guess and you can take surveys and you can do questionnaires and you can do that kind of thing, but you can't prove that it changes another variable. Correlational designs also cannot be used to draw a conclusion about the relationships among the measured variables. And for that reason, that's why researchers often conduct experiments, or they use experimental research, which is what we're going to get into. So, experimental research is used to provide the conclusion piece that correlational research cannot provide. They can't actually come to a conclusion in correlational research. They can test and they can guess and they can make predictions, but they actually can't come to a conclusion. So the experimental research provides a conclusion about the relationships among the variables that we use in correlational research. For example, you do have the placebo effect, is like when participants improve just because they believe they are receiving a treatment. So you can do an experiment and give somebody, even if it's an Advil, you can tell them that it's some other kind of medicine and their behavior or their emotions or their whole sense of being will improve simply because they feel like they've taken a pill to improve their behavior. That would be an example of experimental research. Experimental research is also known as intervention studies or group comparison studies. It does determine if an activity or materials can make a difference in the results for the participants. For example, you can assess the impact by giving one group an intervention and holding it from another group, thus conducting an experiment. So you can give one group the placebo pill and you can give another group nothing, and you can see if the placebo will increase the behavior of the group that it was given to. In experimental research, we have independent variables and dependent variables. An independent variable is a variable that's created or it is manipulated by the experimenter or the person who is doing the research. And you have a dependent variable, which is the variable that is measured and is expected to be influenced by the independent variable. So for example, you have viewing violence on TV would be your independent variable, and aggressive behavior would be your dependent variable, because your aggressive behavior is dependent on what you're watching on TV, which would be the independent variable. This is always confusing for me, so it takes me some time to tell the difference between the two. Your example 2 is decreasing calorie intake, which is your independent variable, and weight loss, which is your dependent variable. So weight loss is dependent on how many calories you increase in a day, which would be your independent variable. Advantages of the study would be experimental research gives the independent variable occurs before the measuring of the dependent variable, so it does eliminate the possibility of a reverse causation, which we will talk about. And it also creates the initial equivalence between the conditions of the experiment. So the experimental research does have advantages over the correlational research in that factor. Although there are some limitations, just like there are in the correlational research, there are limitations in the experimental research as well. Experiments are often done in a lab setting or in a situation that's not really real life. So it's kind of hard to determine that the study done in a lab would have the same outcome as a study done in everyday life. It's not as real and upfront as in, or as much in the natural environment as correlational studies are. And some of the key and most important variables in a study cannot be manipulated, which we will get into here in just a minute, and therefore the researchers must study these relationships using correlational designs. So as you can see, these two do go hand in hand. They do go together, but some of them have more benefits than the other. So as far as similarities, correlational experimental similarities, they are both quantitative research designs, and both research designs are used to collect a series of data, and they analyze that data. So they collect data and they see what the data outcome is. They do rely on one another to get information that they may not be able to obtain on their own. So you can get correlational data and make predictions, but you can't actually determine if it changes one variable to another without the experiment. So I chose two articles, and both articles did have correlational and experimental features, since it is a correlational and experimental research design. The first article is an update on the effects of playing violent video games by Craig Anderson. I did list the correlational features. It was a study to determine if violent games are linked, and I put linked in bold, to an increase in aggressive behavior and aggressive cognition, an aggressive effect, and cardiovascular arousal. The correlational studies reveal a linkage to serious, real-world types of aggression, so you can do this type of research in a real-world setting, not in necessarily a laboratory. And the study also determined that aggressive effects was the same for both males and females. So in this study, not only did they decide to see if violent video games did increase violent and aggressive behavior, they also wanted to see if it was the same between boys and girls. The experimental features of this article was that one group during this study was exposed to violent and aggressive video games, while another group was not. So they were able to find the correlation between the two variables. So they conducted an experiment to determine whether or not, if this group watches or plays violent video games and this group doesn't, and then we're going to assess and look at their behavior. Do they have an increase in violent behavior because of video games? And the experimental study did reveal a causal linkage, which means aggressive and violent video games do have an effect on behavior for students, and it was mostly high school students at the high school age between 9th and 10th grade. So that's the first article that I looked at, and when I turn this in, I will attach the articles. Article 2 is actually the article that I'm doing the article critique on, so it was kind of nice to have this as one of my articles. Article 2, alcohol outlets and substance use among high schoolers. Outlets is like pretty much an ABC store. It took me a minute to figure out what they meant by outlets because I've never heard it called that before. So an alcohol outlet is just like a place where you can buy alcohol. So your correlational features of this study, it did study the relationship between alcohol outlets in the neighborhood environment and adolescent behavioral outcomes, as well as whether or not the more alcohol outlets that they had in their neighborhood, the greater availability to high school age students. So it was one study sample. That was another correlational feature, is that it studied one group of people and not a multiple group of people. Studied 25,308 students from 58 high schools in 12 counties. It did indicate a positive correlation between alcohol outlets and perceived availability. So if you were to plot all the data from 25,000 students, the correlation would be in a positive line, because the more outlets they had, the more perceived availability they had. And it increased in alcohol outlets indicated an increase in alcohol, tobacco, and other drug use. And I did put a quick note in there that it did indicate a positive correlation as well. As far as experimental features, it studied the relationship of alcohol, tobacco, and other drug use among boys versus girls. So they did do the experiment on male versus female to see if that had any difference. They could make a hypothesis and see if, and they went ahead and did the experiment to see if that helped. And they used interviews with students who had alcohol outlets in the neighborhood environment, and also those who don't, to determine if the outlet increases availability. So what they did was they gave surveys to students who had alcohol outlets available in their neighboring and environment, and they also gave surveys to those who don't, and they wanted to test to see if it increased availability as well as other drug use. So those were the two articles that I chose. I did want to go in, since correlational experimental are, linked but different, I did want to go in and just put a couple things in here about correlational research. It is closely related to experimental research. They are similar, but they do have identified differences, which we have talked about. They do not believe that the statistical relationship is a causal one, which means one thing doesn't cause another. So correlational research correlational research is not able to see that, and statistical relationship of interest is thought to be causal, but the researcher cannot manipulate the independent variable because it is impossible, impractical, or unethical. So people use correlational instead of experimental because in an experimental research you can actually manipulate the variable, where in correlational research you cannot manipulate it. And I did give a quick example. They were looking at the number of daily hassles a person experiences versus the amount of stress they have. You cannot manipulate a person's daily hassles. My daily hassles are different than your daily hassles, which are different than my husband's daily hassles. So you can't manipulate a person's daily hassles. So instead, you have to use questionnaires and measure the number of daily hassles per day and record their data in that form in order to get a conclusion. But you can't manipulate daily hassles. They just happen. So that's another reason that people use correlational versus experimental. Who could benefit from this type of research? Really, this was kind of a difficult part for me because I feel like anybody in any job, career, whatsoever could benefit from both types of these research. But I did name just a few. For correlational, I put other researchers because correlational research affects can be used to determine if one variable affects another variable. Psychologists can use correlational research if experimental research cannot be done. They can help their teachers because it's easy to use in a more natural environment. We can use it in our classrooms and see what can help our students versus what's hurting our students. Teachers can use this type of research, especially to look at student behavior, student stressors, etc. And universities use this type of research, particularly in health and social science. So those are some more people that could use and benefit from correlational research. And for experimental research, we have psychologists. They can use experimental research because they believe that their theories need to be backed up by data. So they can